Today, before we get going back into doing matrix addition in assembly? Yeah.
I know you've gone over this so many times, but I really just don't understand that well, like what's offset in this. Like, can you just define each one if that makes sense?
Like what they do, or what they are, or how to use them. So, like the important thing to know when you're working with the assembly stuff, at least for the advanced indexing mode, right, is it looks like this form: displacement, offset, index, scale, right? Displacement has to be some constant expression, right? Offset and index are registers, and scale is either 1, 2, or 4, and maybe 8 in 32-bit mode, right? And what it's going to compute is D plus O plus I times S. So to compute that location in memory, and it's going to go and access that spot. If you look at how this kind of instruction is set up, right, this fits perfectly in the form of doing an array access. Because when we're doing our array access, right, if we do something like array at I plus constant, so like, plus 7, right, if you write this expression without brackets, it's going to be star AR plus I plus 7. Now, if we look here at this expression, and we look back over here at this expression, oops, wouldn't you say like they're about the same thing?
So AR is
Not always, right? D is a constant expression, and AR may or may not be constant depending on the context, right? So what ends up happening in terms of like doing your mapping is like the D field, it'll be equal to like the AR plus the constant times, constant expression, because there might be more than just plus 7, right? Times the size of the elements. But only if AR is a constant label, right? So if AR is a label, it's going to show up in the D field, right? The offset field is AR if AR is not constant. So if AR is held in a register, it's going to be placed into the O field, right? Because you want to start accessing memory from where AR is at, right? Whether that be a constant or whether it be some variable amount because it's held in a register, AR is where you want to start at, right? Then you want to move your constant and then the variable amount. I is the variable index, and then scale is the size of the elements in bytes. Not in bits, in bytes. Right? You only have 1, 2, 4, and maybe 8, right? If we think about just like one integer, an integer is 4 bytes long, or 32 bits, right? And 32 is not an option.
Wait, but is this taking you back 8 bytes? Like, can you get back just 1 bit from this expression?
Yes, not 1 bit, 1 byte.
But you can't access individual bits of bytes using this. It's just
Correct. You cannot access individual bytes using this format instruction, this format of instruction, because memory is byte addressable, which means every address in memory has a byte, which means the smallest unit that you can access from memory is a single byte. Into the registers, you can use bitwise operators on those values to then pick out individual bits within your bytes or whatever your quantity happens to be.
I think I just get confused because we index the bytes sometimes as if it's an index, but that needs to be bitwise and then
Yeah.
index it and then rest.
You're correct. If we're working with bits and we're trying to find some particular bit in some variable, right? You're going to be using the bitwise operators. But if we have an array of elements, we're going to be using standard square bracket notation to index our array, which will be translating to be using the advanced indexing mode. Any other questions about advanced indexing mode? It tends to be the thing that everyone always has trouble with every single year. Yeah.
It's not about advanced indexing mode, but are you going to eventually teach us how to shift?
For the shifting, check out the instructions on the cheat sheet. Shift right there's 2 shift rights. There's SAR, shift arithmetic right, and then SHR, shift right for unsigned right shift, and then the shift left is SHL, shift left. If you're doing a variable shift amount, notice like you want to shift by I has to be placed in CL. So variable shift amounts have to be in CL. It cannot be in any other register, right? If you want to shift by a constant amount, you can totally shift by a constant amount. But if you're shifting by a variable amount, the variable amount that you want to shift has to be placed in CL. It's just how they set up the architecture for the Intel processor. Anything else? Yeah. Yeah, we were like, that's where we left off, right? Last week, where we were doing our matrix addition. So we're gonna go back there and do it. But we also like went over every possible form of indexing you could possibly do in all of the slides that are down here, and they're all expanded out. So refer back to them if you have questions. But we're also going to be going through it again today as well. So need this. Some of you guys were having trouble getting the pretty highlighting, and so what you can do is you can just make a .s file in CLion, and type in CLion, and it'll be pretty. It'll do all the highlighting for you automatically, and then you can just copy and paste that over to like gedit or whatever your text editor is that you're using somewhere else to compile there. So, if you remember, last time we left off, we were trying to translate this one line of C code. Yeah.
It's more of a nuts and bolts question, but I know you can move fairly quickly on there, whereas for me it takes kind of a while. Is that because you're like SSHing into the CIF or doing something special, or do you just have a fancy configured thing?
I'm just accessing it on my own local machine. I'm not connecting to the CSF at all.
Okay, and your virtual machine is just that fast?
Yes, I made sure to give it lots of memory and lots of processing power, and I have a decent computer too that helps out too. Cool. But yeah, it is a heavyweight process when you're doing the virtual machines.
Could you just connect to the CSIF and will that work? Or?
Yes, you can just connect to the CSF and that'll work, or if you're in Mimir, you can use the Mimir IDE and do your work there, but if you're connecting remotely, you might be limited to only like the terminal-based applications.
Okay,
You won't have access to the GUI ones.
Okay. Thank you.
So we're trying to translate this expression right here, right? And since we are doing one big chunk in terms of how our arrays are laid out, it translated to this equivalent expression over here, right? Very, very long. But again, like with everything you do as a computer scientist, when you're faced with big problems, what should you do? Break them down, and break them down, and break them down, and break them down, and break them down until they're finally small enough to there's something that you can do. So there are 3 major portions here: getting C, getting A, getting B. So we wanted to start with getting A, right? And we wanted to put that into EAX. That's what you guys said that you wanted to do. So we had to do A plus row times num columns plus call, right? And if we look back up to our comments, we decided that we wanted to use A as a label in memory, right? That was the choice that everyone decided to make. That's perfectly fine. So just remember, A is a label in memory, EBX is B, ECX is C, EDX is row, and ESI is call, right? We also said, so these are like our notes to ourselves so that we don't forget what the heck we were doing and what registers are supposed to be what. So always do this, otherwise, like you probably are like now, you're like, what the hell were we doing last week? Or whenever it is that you have to come back. So good comments are extremely important when you're writing your assembly code. Right? So in doing this expression, right, we can break it down farther. The first thing that we want to compute is row times num columns, right? So over here we decided to move num calls into EAX, and then we did our multiplication. Remember, when we do the multiplication, it's always your source, right, times the result. or times EAX, and the result is stored in EDX EAX, with the upper half of the result being in EDX and the lower 32 bits being in EAX. We know that our result's only going to fit into 32 bits, so we don't really care about what goes into EDX. But don't forget, it gets overwritten when you're doing this operation. So we do our multiplication, right? So EAX ends up with row times num columns, because again, EDX, if we look back, it's the number of rows. Or it's not the number of rows, it is row. Which row we're on. Then we wanted to add ESI to that. Remember, if we scroll back up, ESI is going to be call, what column we're on. So then we add call to it. And then we use the advanced indexing mode, right? Referring back to the question we had earlier, A is a label in memory, so it goes into the displacement field. We do not have any constant parts in this expression, so no other constant part of the expression is going to go into the displacement field, so we don't have anything else. Since we don't have our register in, since the beginning of our array is in a label and not in a register, we're going to use the offset field as blank. The index field is going to be EAX because that's where we're trying to index our array at. And then word size, which is again is 4, goes into our scale because we are dealing with an array of integers. And we move that into EAX. So now EAX is equal to A at row call. Again, though, we ran into one small problem that we briefly mentioned at the end of the class, is again, this expression is going to change what's in EDX. Now, do we have something in EDX that we care about? Yes, right? So if we do this expression as it is right now, we're going to lose whatever happens to be there, right? So what we can do is we're going to have to save that value somewhere. And where can we save it at? What are our options? Where can we put things? I'm hearing someone whisper it. We could put it into another register, but we're running pretty short on registers at the moment. We only have about one left, EDI it looks like, and we might need that for something else later on. What are our other options as to where we could put it? Right, we could put it in memory. So let's say we wanted to put it into memory. How would we go about doing that? Well, the first thing that we have to do is set aside some space in memory for this variable. So how can I make space for my variable up here? Yeah, we have like a label called row. And how much space do we want to make for row? How big is it? Right? Row is an integer. How many bytes big is an integer on a 32-bit machine? It's 4 bytes. So how can I make 4 bytes worth of space? Right? We could do .long, and we can just give it some value, 0. Are there any other ways that we could create space for this besides .long? Dot space followed by 4. We could do dot space 4. Any other ways that we could do this? Right? So another alternative, which we're not going to be doing right now, would be like dot space 4. That would make space for 4 bytes. What would be some other options? What other directives do you know that make space? That's not dot short, but dot word, right? So you could do like dot word 0, dot word 0. Every dot word makes space for how many bytes? 2. So if I put 2 of them next to each other, that makes space for 4, right? Probably we wouldn't want to do this way because it's a little confusing, right? We don't actually want 2 shorts here. We just want 1 4-byte quantity. But doing this and doing that and doing this would all be equivalent. The final way that you could do it is you could do dot byte 4 times. Dot byte, dot byte, dot byte, dot byte, dot byte. Again, probably not the most clearest of intentions, but again, it makes 4 bytes worth of space. Yeah.
So if you do dot space 4, then what's initially?
I believe it defaults to 0 if you don't specify a value.
So can you do like dot long and nothing there?
I think the dot longs require an initial value. I'm not 100% sure, but I always do. And if you're not planning on using the initial value, does it matter what you make it?
No, but the dot space, can you initialize the values?
I think you might be able to if you like do like the amount of space and then comma and then what the value you want to be, but each byte would be initialized to that value, right? Not because like even if you made like a 4-byte quantity and you said something like 10, you'd have the pattern 10 repeated 4 times, one for each byte, not for one element. It's just 10. Yeah. But like if you go and you look up like the GNU assembler, like the preprocessor directives, and you search it up, you can find if it supports the option of specifying values for space. But normally when I'm making space, I don't care. I just treat it as uninitialized. I'm like dot space, whatever. There's some space there. Yeah, generally like dot long is a little bit more like intentful than doing something like this, and it better communicates how many things you want there, right? If I do dot long one element, you're kind of assuming that I just wanted one unit there that's 4 bytes big, versus doing dot space 4, you're probably saying I want 4 1-byte elements. But again, you could treat them as one 4-byte element too, or two 2-byte elements. But the intent is probably less clear there. So those are some options. So great, we now have our label in memory for row. So how can we save it before we do our multiplication? Question was, how can we save what's in EDX row out into memory at location row at that label? Yeah, it's going to be move L because we want to move a value, and we want to move what thing? EDX, right? And we want to move it to? Yeah, to row. So save EDX because it will be overwritten. Written by the mul. One thing that we can kind of also notice is in doing our expression here, the C at row call, A at row call, B at row call, is there any things that get reused in those expressions? Not even just row and call. It's a little bit more than just that. Not EBX. Again, like if we look at these expressions, like this expression, what does this expression have in common with this expression have in common with this expression? What parts are the same? Row times num calls plus call, right? So we could recompute this value for every single one, or compute it once and then reuse it, right? But what would be the problem of reusing it right now? Yeah, we just overwrote it, right? On line 90, we replaced what's in EAX, the index, with the value at A, right? So instead of putting this into A, where might we decide to put it instead of in EAX? Given which registers do we currently have free at this point in time? We have EDX is free, and anything else? It's also like EDI would also be free too, right? It's not mentioned, we just never used it. So do you want to use EDX or do you want to use EDI? EDX? EDI? I think EDX wins. Again, there's no benefit over picking one or the other. You just got to pick one, right? So we're going to change this to be up here. We're going to change this thing to say EDX is going to be equal to A plus row times num call, right? That's our goal. And then over here, we can still make this happen, which happens here on this line. But now, just to fix our code to make the above expression happen, we can just move out EAX to EDX, which means EDX is now equal to row times num calls plus call. Sound good? Any questions before we keep going? Okay, so great. We got EAX into this register. How can we add EBX to it? Let's say now we want to get EAX to be equal to A at row call plus B at row call. Again, if we go back up here, we said that B is an EBX. Right? We can do this with much less work because we've already computed all of that. Right? So we already have that entire expression stored where? It's an EDX, right? So now, how can I take B at row call and add it to EAX to compute the sum? Right? Add L. And we want to add L what? Well, how do we get B? Essentially the same thing, but we said that B is an EBX, not a label. That's what you guys wanted to do. So how does my advanced indexing mode change? Right? Given that B is an EBX, right, and it's not a constant, are there any constant parts of this expression? No. So we would put anything in the D field? No. So the D field is empty. Right? Since the start of our array, it's not in a label, but is instead in a register, what are we going to put into the offset field? EBX, right? The beginning of our array. Right? Now our variable index amount goes where? Into the next field, right? The index field. So that's EDX. And then the size of each element is 4, right? Which again, we made that EQ word size, which is 4. And we want to add this to EAX. Fantastic. Any questions here? Yeah.
Could you have done that in 2 lines with adding EBX to EDX and then adding EDX to EDX?
But EDX is just an address, right? So what would you want to add to EDX? You want to add EBX to it to compute the entire portion?
Well, I thought that EDX had the row times num calls plus call.
EDX does have row times num calls plus call. So you want to add EBX to that? So you want to do add L EBX to EDX? The problem that we have here is this variable amount, it hasn't been multiplied by the scale yet, right? So this is would only be in terms of, this is how many elements we want to move, but we haven't multiplied by the size of each element. If you add EBX to EDX, there's no way of now doing the multiplication by the correct scale to make that happen so that you move over. What you could do is you could first multiply EDX by 4, just shift it to the left by 2, right? Get you the same effect. And then add EBX to it, and then you can just have one element, and that would work. But the problem of doing that is we now want to use that same value for C, which again would require us to recompute it or resubtract out those things that we did, which is probably going to be more work than what we did here. But yes, there are definitely alternative ways of writing this with more lines, but I didn't want to. Any other questions? Okay. Now finally, we want to do C at ij is equal to A, or not ij, row call is equal to A plus B at row call. So how do we go about doing this line of C code? Oops. Well, tell me what the same thing is. Well, I mean, are we doing an addo here? Right? We've computed this value. This value is stored in. This value is stored where? EAX. So what do you want to add? Right? Given that you have this value and you want to put it here, do we need to do any addition? Okay, move what where? To ECX? Like this? Well, yeah, because we want to definitely access memory, right? But this is going to put the value where? Where will this put the result at? So if we do the line as written, right, this is EAX is the sum. Where will we place the sum if we do the line as written? So I have the first location of ECX. How many are in agreement with that? Okay. Any other proposed ideas as to where this will place it? Discuss amongst yourselves as to what you think? Or did you have an answer? Yeah.
It's the same as the 997. You do advanced indexing mode, but you change EBX into ECS.
Yeah, that's what we're going to end up doing. But my question right now is, what does the line as written do? Where do we place the sum at?
Would it just overwrite ECX entirely?
Yeah, it just puts in an ECX. Because what's on the right-hand side? What's in the destination? The destination is ECX. So you're going to take the value and put it into ECX. Right? Because that's what the destination is. The other suggestion was, like, if you wanted to put it into, like, C at 0, that would be C0. Or C00. Right? But over here, right, we need to do it at the advanced indexing mode, so as I suggested, ECX word size. Now, quick question, is this line of code that we have right now, is it equivalent to these two lines of code? How many believe lines 100 and 101 done together are the same thing as line 103? Does anybody think that they are different? For those of you that think they're different, what does it do if not this? Not the same thing as line 103. What's it do instead? Talk amongst yourselves for a minute and see what you think, if these lines are equivalent or not, and if they do the same thing. So discuss amongst yourselves to see what you think is going to happen. Are they the same? And if they're not the same, what do they do? Say it again? Well, it's just because it's really low level and there's a lot going on. And you know how I hate people writing gigantic functions in like C++ and everything else, other language? Like, this tends to be one of those things where there's a lot going on at once. And so it's hard to keep track of every little moving part. But it's also kind of hard to like break it apart into smaller chunks too, because we're trying to do like one line of code in terms of our translation.
This is one line of code.
So like these lines of code right here, we're just this line of code that we're trying to translate right now. So we're just trying to translate C at row call equals A at row call plus B at row call, and it's taking us, something like 10 lines or something or more to make happen. but I'll scroll back down.
Where are people at with homework?
What?
Where are people at with homework?
You getting started, I think. I mean, you've been out for a couple days. Nice to see you back.
Yeah.
Did you get sick? Okay. Glad you're better. It's a bad one. Mhm. Okay, so you guys have had about a minute to discuss. How many of you guys believe that these two, or these two lines, 100 and 101, are equivalent to 103? How many of you believe they are something different? For those of you that think they do something different, what do they do if they do not do the same thing as 103? Yeah.
So the two L's in a row into EDI, would the second one override the first one? Or is it like one?
Oh,
one? Yeah, so I move out 2 times in a row. Is that like, because you're calling everything an EDI both times, so the second one overrides the first?
that is correct, right? But are these lines of code the same? And if they're not the same, they're different. What does lines 100 and 101 do versus what does line 103 do? So let's break down line 100. What does line 100 do? Right? This is going to make EDI equal to, right? What's this going to? This is going to make EDI be equal to C at row call. And then this line of code, what does it do? EDI is equal to, okay. So that's what those two lines of code do. Does that accomplish what we wanted to do? No, this one changes EDI. This one changes, what does this one change? It does not change ECX, it changes C at row call, right? Because we said go to memory at ECX, which is, I believe you guys said, it's C, at C, and this is the row times call plus blah. This is going to get you the row call, right? So this actually changes what's in memory at the location. This changes EDI. This, though, is one of the biggest mistakes that I see all the time, because you're like, well, EDI is C at row column, and so if I change EDI, I change what is at C at row call. What was wrong with that statement that I just made, right? So again, I said the first line says EDI is C at row column, and then line 101 says EDI is equal to A at row call plus B at row call. What's wrong with what I said there? Say it again. But is EDI C at row call? No, what is EDI? Well, that's what ends up being. But like on line 100, is it true that EDI is C at row call? It's a copy of the value at C at row call, right? So in doing this line, you make EDI hold a copy of what's at C at row call, right? You do not make EDI become C at row call. They are not the same thing. They're two different things. One is in memory. One is inside your CPU, right? One's a register. One's a memory location. You can copy what's in this register to some memory location, or you can copy what's at some memory location into the register, but you cannot make the memory location and the register be equal. They're two different things, right? They're two separate areas in your computer, right? And since they're two physical different locations, they can never become one thing. If that makes sense? So don't do this. It's really bad, but I promise you some of you still will. Don't do this. Watch out. But I know I will still have to address this problem a couple of times, at least in office hours. So, are we done with translating that line of code? Is there anything else that we need to do? No, we're completely done. Yes, we still have some loose ends to tie up. For those of you that think there's some loose ends, what do we still have left to do? Say that again? Yeah, right. So this is the one line of code that we were translating. We've already translated the 2 for loops on Thursday.
If you're gonna not get overwritten on complete, do you need to save the value elsewhere, or is it just now?
Save, what is it? Whose value do you want to save?
So like when you go through the loop, I guess it's not getting overwritten. And then to put it in the right spot so that.
Well, yeah, remember we're changing C at ij, right? And I and j will be different every time, so we won't be like, unless we screwed up, we won't be changing the same element multiple times. So are we good? You forgot to do something. Has to do with line 87. Right, we saved this value out into memory, but you know, down here, hey, it looks like we're still treating EDX like it's row, but is EDX row anymore? No, so what do we have to do? Put it back in, right? Go take the value that we temporarily set aside in memory and move it back into our register so that it's back to being row. Right? Restore EDX back to row. So then over here, how can we do that? So should this be row or should this be $ row? How many think it should be $ row? How many think it should just be row? For those of you that think it should just be row, why do you think it should just be row? You must have some reason you believe this, right? Right? You must justify your answer to somebody, like, why the hell did you do this? Why do you think it should be row? I'm not saying you're wrong. I'm just saying, why do you think it should be row and not $ row? Correct. $ makes it be a constant, so we'd be putting the address of row into EDX. But we want to put row itself, the value that's there, right? This is just using the advanced indexing mode, but we only gave the displacement field, the constant portion, the D part. We did not give O, I, or S here because we don't need them. So fantastic, we're done. Translated 3 lines of C code. Any questions? Yeah.
This is horrible. Is there not a better way to do this?
Well, I mean, that's what you have. That's why you write C code in the first place.
Yeah.
Right? Somebody wrote something so you didn't have to do this. It's called the compiler. Right? It translates your higher level language down into the assembly code, which then gets translated into the machine code.
What's compiler written in?
Well, the first compiler was written in assembly code, but then after they got their first compiler working, every future compiler was written in the old compiler.
That's really cool.
Right? So like if you're going from like Java 7 to Java 8, the Java 8 compiler was written in Java 7. I mean, it works, right? It produces Java code. You just have to now work up your program. So generally it tends to be that each Like the first compiler had to be written in some other language besides the original because there was nothing to interpret or like compile the original. And then everyone after that, you just use your older compiler to produce your newer compiler.
Is it true that GCC is written in C?
Yeah, because after they got the first one, their newer versions can be written in the old one. But again, they don't have to do it in C, but they could. Or they could do it in C++, just some language that works. You can produce your compiler for your new language. But, assuming the language you write your compiler for you like, why wouldn't you want to write in that language? That's probably what happens. Any other questions before we keep going? Right? This like assembly code has one of those issues that I don't like in terms of normal programming, where you have a lot of code in one area and the problem's not terribly broken down. The hard part is with the assembly code, it's kind of hard to get around that, which is why I like to do the comments for which line of code that I'm translating, what I'm doing. So I try to use the comments to break down the sections as to what should happen instead of being able to have functions to make that to accomplish that same problem-solving strategy. But let's go see if this works. So great, we have our thing. How should I assemble it? What's our command to make that happen? I know some of you know it because you've been doing your homework and you've gotten it to run. We make, but if you look in the make file, right, you're gonna find the commands there, right? To make the O file, which depends on mat.add.s, it's as --gstabs --32 -o, name of object file, mat.add.o in this case. Then we're going to make that from mat.add.s. To make the executable, we're going to run the linker -m, specify the 32-bit linking, -o mat.add.out, mat.add.o. So yes, we can't just run make, and because I wrote that for you, it will run make. But again, you can just see the commands here. It's just as followed by ls, right? And make sure you set the commands appropriately. And if we're going to debug it, we're going to be debugging it in ddd mat add.out. Is it not? Oh, okay, I put an underscore there. Boop. So over here we can break at done, and then I can run it. Something probably didn't quite happen, right? Oh, I don't have a line of code there, that's why I can't show anything. Hold on, let's make one small change. So when you're doing your homework assignment, make sure you have a line of code after your done label. So we're going to have no op here. And then make sure there's a blank line afterwards. Otherwise, your output on GDB won't match mine. So we'll rerun this with make. We'll run ddd again. We'll break it done. And then we'll run our code. Great, we got down there. And if we want to see our values, it's graph display. And now we have to do some fancy casting. So integer pointer, the address of C. So we're going to treat C like it's a pointer to an array of integers, because that's how it's going to behave, right? We are then interested in seeing the element starting at 0. And then at, well, we want to see 12 elements. So 3 times 4, which is 12. And press enter. And ta-da! We have all of our numbers for our result. And so what we'd have to do is go back and compare them with the values that we have here with whether that makes sense, right? Like 10 plus 100 is going to be 110, right? Or 42 plus 1,200 is 1,242. So everybody seems to be in the right order. They seem to have the right values. Do you want to go through it a little bit slower to see it be computed? Anybody? Or do you want to go with this? Okay, we can go through it a little bit slower. So break it underscore start. Oh, I gotta be in the box. And then we can run again. And so again, it's probably going to be useful to see the values that we have in our registers. So we probably want to see something like, well, what's EDX, which is going to be a row, and ESI, which is going to be column. So graph display $EDX and graph display ESI, which is column. Right? So we start going through our program. We do the comparison, right? 0. We should still be in bounds because of the 3 by 4. We do our comparison. So now we're doing the part where we're actually computing the values. So we probably, again, we already have EDX showing up. So hopefully we should end up computing 0. But it looks like we might also want to see what's in EAX. So we can graph display $ EAX. And after we do this line, hopefully it should have the first value from the array. It does. It has 10 in it. Right? Now we should add the first value from B to it, which was 100. So we should get 110. Great, we got 110. Now we should go put this value into location 0 in the array. It's there. Right? The 110's there. We reset row back to being 0. We increment ESI, go to the next round, and we're now computing the second element. So we should get the second element from the array, which is going to be 20. And if we scroll back up, the second element is 20, and the next element should be 200. So we get 20, and we're reading the right thing. We add the 200 to get 220. We then transfer that value to the array. It's there, and we can keep going around and around and around and around and around, seeing each of the elements being added, right? We could probably even do something like, I want to break at line 108, and then just continue. And you can see the values getting filled in one at a time as we keep stopping there. Yeah? So a .out file is a fully compiled, ready to run executable. So it's an actual executable file. A .o file is a partially compiled file that hasn't been linked together yet to produce an executable. So it's a partially compiled file that you cannot run directly yet.
So which one do you separate?
So right now we're debugging the out file. You only debug executables. You don't debug partially compiled files because they're not runnable. Any other questions? Again, you guys are going to have to get used to using the debugger. Your code will not run outside the debugger, right? So make sure you get some practice with it. It'll also make your life better in the future because you'll actually know how to use one. So great, we finished that. Now, what would happen if instead of having an array of arrays, instead of having one big chunk, we had an array of arrays? How would we change our code? So, array of arrays. And so if we go over here, again, first we'd start with our C code. How does that look different than our other code? Right, here's version 1. This is what we just did. How is that different from version 2? Okay, here's version 2. Again, version 1, we're playing spot the difference. What's different between the two? Again, back to version 2. Yeah?
On the arguments, if they're pointers.
Yeah, right. That's the difference, right? The rest of the code you would write identically, except the parameters are going to be changed, right? Here we're saying I would like one big chunk arrays that always have 4 elements per row. Here I'm saying I want an array of arrays, right? Num rows and num columns get passed in. So in terms of translating this code, what's going to be different between version 1 and version 2? In terms of what we would write here in the assembly code. Yeah?
For arrays of arrays, it's dynamically allocated, so you have to use like a register instead of a constant?
No, I mean, it depends on how you do it. So like here is how we have things set up. So I did not dynamically allocate it because I don't want to get into function calls yet. But over here, right, here's my array A. Well, it has 3 elements, right? Because it's going to be, again, be a 3 by 4. And each of those is the address of each of the rows. Right? And then here's B. It has the address of B's rows. And then C has the address of C's rows. Right? And I move some of these things around to show you that it doesn't matter, but I also kind of like putting them next to each other because it helps readability if you put them as we had them before. But I just want to show you that we can move different parts around, and it won't matter because we have our array of arrays, and we have pointers to those spots. So each individual row can kind of like be wherever the hell we feel like in the data memory, but the contents of an individual row must be next to each other. They must be at sequential memory. Right? So do you think the for loops are going to be translated any differently? No, right? They're like the same thing. But what about this line of code? Line 6. Do we do translations for array of array accesses the same way we do one big chunks? Hopefully your answer is no and you did your quiz. And you put no and you did the right answer for each one in quiz 1. Right? They are accessed differently. So I'm going to leave a lot of what's here already here. And let me change my visibility so that the highlighting is nice. Highlight mode is assembler. Let's see. So again, here we have like our outer for loop. So EAX is going to be row, EBX is going to be call, and ECX and EDX we'll use for temporary things. So this is translating the inside. So we want to translate this line of code. So again, every single time you see those square brackets, you should be like, I'm going to rewrite that without square brackets. So what's this line without square brackets? Right, just like we did the prior version without square brackets when we were doing the translation. Think back to your quiz. You have already done this. You know what to do. No? Yeah, I'm going to follow all the pointers, right? So what does following all the pointers look like? What's the... yeah. That's totally what it's going to be. Plus call, right? And then this entire thing dereferenced, right? So that's what we have to do. And then the same thing, it's going to be equal to A plus B. But it's really important to know how these expressions are written without the square brackets, so you do the correct translation, right? If you did a one big chunk translation for how the memory is actually laid out, it's totally going to crash because that's not how it's set up, right? You want to treat it as memory is actually laid out. So which part do you want to do first? Remember, EAX is row and EBX is call, and everything else we don't know about. I mean, it's up to you as to what you want to do with it. So again, we have this one gigantic, really big, huge line. What should we do? Break it down. Again, that should always be your first kind of idea. You want to specify what to do, like with the minimal possible detail, right? So we're going to just do this part right here. Right, this is the line of code that we want to translate. Do you want to put this somewhere? Again, EAX and EBX are currently in use. Everything else is free. What? EAX and EBX are in use. So probably don't want to reuse one of them because you'll lose what you have. You can pick any other register besides those two. It doesn't matter which one you choose, you just gotta pick one. So which register do you want to use? Sure, ECX. right? We want to make ECX equal to this. And again, if you break it down, how can you break this problem down to be something a little bit smaller than what it was before? Right? We can do this part right here. Right? How can I get that into ECX? How can I make ECX be equal to this? Notice you see a dereference operator. Because you need to dereference and access memory, what should we be using? Yeah, the advanced indexing mode, right? As soon as you access memory, you're like, advanced indexing mode, I have to use that because it's the only thing that lets you access memory. So in this expression, A, is it a constant or not? A is a constant. A is not a constant. Most of you vote that it is a constant. So since it's a constant, what field does it have to go into? The displacement field, right? So move L, A, right? And since A is a constant, are we gonna, and it's the beginning of our array, are we gonna have anything in the offset field? No. What is our variable index? Row, and row, I believe we said is held in EAX. So what am I going to put in my index field? EAX. And how big is each element? Right? What are the type of our elements? What are the type of our elements? I mean, I will agree that they are 4 bytes big, but if we think about, like, you know, what the type is back from the C code, what is the type of the elements of A? Integer pointers, right? Again, it's just one of those things that you have to be really careful and really, really detail oriented as to what you're doing. Otherwise, you're going to end up with some bad assembly code that's not going to work. So it's going to be an integer pointer. I just want to, like, you know, harp on that so that you know what you're doing and why it's going to be 4 here. So word size, that's 4. And we want to put that into, what do the comments say we want to do? Right? And notice, we didn't write the code first. We wrote the comment first, right? Start with what your goal is. Backtrack to make it happen, right? But know what you want to do first before you go and try and do it. Otherwise, you're going to have a very miserable life because you will accidentally do something that you didn't intend to do, or you'll have no idea what to do, and you'll just do something because I must write code. It's important I get graded on this, and then you'll put some garbage code down, and it's not going to work, right? So be intentful. So now, how can I finish this and make ECX be equal to the entire expression? Right? How can I finish this up? Right? Remember, this value is held where? ECX, right? Not add L, because again, we're dereferencing, right? So again, if we break it down, where do we want to start? Where do we want to start in memory at? Where should, like, the beginning of our array be? Right, this is the beginning of our array, right? We've already gotten here. We've gotten to this particular row, and we need to move column elements into it. So again, if we think about this as our AR field, right, is this constant or variable? Constant. Variable. Okay, everyone else, what was my third option I didn't pick? Because again, you have to identify as one or the other. Is it constant or variable? So let's break this down. When we did this part right here, was A constant? Yes. Was row constant? No. So a constant plus a variable will make what? variable. It's going to be a variable amount, right? Because a variable, I don't know what this is at this point in time, plus some constant is still, well, it's that much constant bigger, but I don't exactly know what it's supposed to be, right? So this part here is a variable amount. So what field is it going to go into, given this is where we want to start reading from? The offset field, right? So move L, we want to start reading from ECX, right? How far past ECX, star A plus rho, do we want to go? Call, and call's in EBX, so we put, and then what should our scale be? Word size, 4, right? But why this time? Because the elements here are, yeah, they're integers, right? So that makes sense. Great, we've now accomplished this one line, or part of this one line of code. We got ECX to be equal to A at row call. How can we add, B at row call to that? Or what do you want to do next? What's your next little sub goal to accomplish here? Sure, we can copy and paste it, but we want to do it with, we don't want to do this with A anymore, we want to do it with B. Sure. And do we want to put that into ECX? No, because we already have something in there that we care about. Where do we want to put this into? Again, currently A through C are in use. Sure, EDX, right? It's not really a big deal. So here we have EDX, and so this line of code should change to, this should change to B, okay? And this should change to D. And this should change to D, and these should change to D's. And this right here should change to, it shouldn't change, should question. And this one should change to, sure, EDX. Now, where do you want to put the sum of these two things into? Right, because right, you have A at row call, you got B at row call. We got to add those two things together and store them somewhere. So where do you want to put the summation? Well, I mean, so we have either ESI or EDI. Those are totally available. But also ECX and EDX are available, right? Because we don't need those anymore. We have the values, right, that we need. So we can sum them. So we could do addl, just say like %EDX, %ECX. And this is going to make ECX be equal to A at row call plus B at row call. As an alternative, we could have saved this additional line if we had changed this from a moveL to an addl and from this EDX to ECX. Right? This could have been addl B at row call to ECX to get the summation there. Right? We could have saved ourselves one tiny line of code. Now we have to put the C at row call, make it be equal to there. So how do we do that? Guys are going to want to hurry because I still want to show you functions, or at least how to kind of get to them, which will help you out in your homework assignment. So again, like what we're trying to accomplish is this little portion right here, or maybe this line, depending on how you want to think about it. So, oops. So the first thing that we can do is move L, what? C, right? Past EAX, word size to maybe EDX, because EDX was freed up. We don't need it anymore. We have the sum, right? So this is EDX is equal to essentially C at row, or again, this guy right here. And then what do we do next? Right, this is EDX, this is C, C at rho. You want to put it where? Sure. Okay. And then we already have the sum. Yeah, you just made it again. The one I said not to make. You just did it, right? But you caught it, which is good, right? Because if you did this, what would that do? Or oops, right? This would do EDX is equal to but what did that change? What did we change here? We changed EDX. Did we want to change EDX? No, we wanted to change what's in memory. But again, a very easy mistake to make, right? Because we're like, oh, I'm just going to keep following that pattern, right? But no, not quite right. Don't do this again. Don't do this. It's not what you want. Okay, what can we do instead? Oh, I should comment these out because we don't want to do them. We want to take our value, right, the sum. What's the sum in? ECX, and we want to move it to, C at row call, right? We already have C at row, and yes, we can use the advanced indexing mode once again to say, go transfer it to this location in memory, right? There better be a location in memory on the right-hand side if we want to put our value in to memory, right? So what's our first parameter going to be? Yeah, and this will make C at row call be equal to, come on, be equal to A at row call plus B at row call. Right? Because notice, this expression over here on the right-hand side, what is it? It's the location of memory of C at row call, right? And so I want to put the sum at C at row call. So I wrote the code that says take the value of A, A at row call plus B at row call, and put it at C at row call, because that was what I wanted to have happen. So C at row call better appear on the right-hand side, not a copy of the value that's there. EDX, which is what we got before. Any questions? So you definitely know enough to do like the first 3 problems for your homework assignment. The next one, you're probably going to want to see some functions. So how can we accomplish those? Functions are actually pretty easy, but we're going to refer to them as subroutines for right now, not to get them confused with C-style functions. And I only got a couple minutes, so I'm going to go a little bit fast. So let's see. Nope. Sure. cd into fun. Should it stir fun.s? Oh, that one's very much the C style type. It's not the one I was looking for. Well, we'll just make a new directory and we'll go through that. So we're going to make a directory called, what do I want to call it? Called it subroutines. And if you are looking at the books, it totally talks about this. So let's say we want to write a function that calculates the length of some string, right? First thing to do is write it in C code. So what's the C code that's going to find you the length of a C string? I'm just doing other things. I'm just waiting for you guys to start talking. So what defines a C string? What makes a C string a C string? It's an array of characters that ends with a null character. So if you want to figure out how long your string is, what do you need to find? The null character, right? So over here, we might have something like int len is equal to 0, right? So then for, we already have len equals 0 there, right? We want to keep going for how long? Right? So we want to keep going while stir at len does not equal to the null character, right? Plus len. Well, is there anything we actually need to do in the body of our function? No, right? Because we're just counting. So I'm just going to put a semicolon there. We do nothing. Or, you can write it as my body is empty. And then we can just return len, right? Now, the things here that make functions somewhat interesting is we have to specify how do you want to pass your values? How do you want to get the values into your function, right? And the way that you first start your function is you make its name, which is just a label. And I recommend doing your functions above the underscore start because you won't accidentally run them when you don't intend to. Because again, if it's below underscore start, you just keep going lines beneath underscore start. And if you run into your function, you just start doing it, right? And I'll also put like an end of strlen under here, but it doesn't actually do anything. It's just a nice little marker. When you're done with your function and you want to go back to where you were called from, it's just ret, right? Just go back to where you were called from. Notice I didn't say anything about what when I say what ret did. What didn't I say the ret instruction did that you're used to seeing with the return keyword? The value. Ret does not return values. It goes back to where you were called from, right? So now what we have to do is we have to define some rules, some conventions for how we'd like our function to be used, right? We're kind of describing how you need to get the values in and where you should look for the return value. So how might you decide to pass values to your function? What are some options you have? you could pass the values through registers, right? So you might say that before you call my function, right, stir should be placed in, what register do you want to choose? Sure, ECX, right? You pick a register. You're your own boss now. You make the rules, right? But you just gotta make sure that you should probably be consistent with your rules in terms of applying them, because that uniformity will make writing your functions easier. But you just have to say what's supposed to happen, right? So we're gonna say, before you call my function, I expect that you put stir into ECX, right? What would be some other options besides placing the value into a register? You could put it in memory, right? So we might call this one like strlen reg and strlen reg. Over here we have the .data section. And then we might have another version that's called strlen mem, right? Depending on how you want it to be passed. So you might say that stir should be placed in strlen stir before calling, right? And then so down over here in the data section, we'll just create a label called strlen stir. How big should this space be, given that our function wants this as an argument? Yeah, it's .long because the type of stir is a character pointer, right? It's a pointer. All pointers are 4 bytes big, right? So for returning a value, how could you return a value? What might be a way of doing it? Put it in another register, right? So you might say the return value will be in, sure, EDX, right? Now, here, again, another optional way of saying is like the return value will be in strlen ret. And then down over here we have, let's put 0 here, strlen ret. All right, it's an integer, so it's 4 bytes big. So when you want to call the function, you say call function name strlen reg. So if over here in the data section I have my string dot string, I think it is, and then hello, right? If I want to call strlen reg, what should I do before I do the call? What does it say I should do if I want it to work right? Right? We have my string, and we should better make sure that we put my string into ECX, right? So we'd have something like movl $ my string into %ECX. Now I do the call. Where should I look for the answer after the call completes? What did we say? EDX. So you just look in EDX, right? And then on Thursday, we'll put the rest of the code in here to make it actually happen, right? But you just set up some rules for how things should work and make sure you follow them. The important thing is, before I do this call, if I have something in EDX that I care about, what should I do? Save it somewhere else, right? Because we know that this function, it's going to overwrite EDX, right? And it might also use some other registers as well. And those other registers, we have a choice. Either the caller can save them, my function can save them, or the function that calls me can save them, like what they've been doing right now, or the callee, the function that's called, can choose to save those other registers. And you just have to make a choice about whose responsibility that is and follow through on it, right? We drive on the right-hand side of the road in America, so you better drive on the right-hand side of the road. Otherwise, bad things happen, right? Follow those conventions. We'll finish this on Thursday, and you'll totally be able to do the last problem. You mean you know enough how to do it now, just break it down to functions to make your life a little bit easier.
Excuse me, Professor.
Mhm.
I want to follow up